Hello friends, good evening. Once again, I am Gourav Gupta and I welcome all of you to BYJU'S Exam Prep, which was formerly known as Grade Up. Now friends, BYJU'S Exam Prep is the most comprehensive app for all the examinations, including MBA entrance examinations, which are CAT, XAT and other examinations. Now here at BYJU'S Exam Prep, we provide our aspirants with end-to-end preparation so that they can achieve their desired goals. Now friends, here I am once again Gourav Gupta to basically help you in making the concepts, the fundamentals of algebra strong so that you can increase your percentile in this examination. All right. So friends, yesterday we have started with algebra. Some of you must have attended that session. All right. So yesterday we started with algebra and we basically looked at the basic concept of polynomials, which included addition, subtraction, multiplication, as well as division of polynomials. Later, after that, we basically discussed a remainder theorem, which was helpful in factorizing a given polynomial of 2 degree or 3 degree or maybe higher degree polynomials. All right. Now in this session, I'm going to present or I'm going to discuss some of the algebraic formulas without which the life is very difficult in these examinations. All right. Now these algebraic formulas will help you in a lot of ways. Yes, friends, these algebraic formulas will help you in a lot of questions, and like if I'll talk about basic level questions, definitely they'll be helping you in quadratic equations, they'll be helping you in simple equations, they'll be helping you in solving some of the basic values. Also, these algebraic formulas can create a big difference between your percentile. Okay, now there are a set of questions which looks to be very difficult. I have included some of the questions like that in this session today. So there are some questions which will look very difficult, and they will depend on the direct application of these algebraic formulas. All right. So if you know all these algebraic formulas by heart, and like you'll be able to apply these formulas at a right time, then you'll be able to answer, you'll be able to solve these questions which will make a lot of difference, which an average student may not solve and you'll be able to solve it. Okay, so it will help you in increasing your percentile considerably. All right, so let's start with this chapter. So first of all, let us have a look at the basic algebraic formulas, the basic ones. Okay. So if I'll start with basic formulas, all right, so I can see a plus b whole square. So a plus b whole square is a very basic formula. All right, and we know its value, it is a square plus b square plus 2ab. All right. Now look at the way I have written this formula. Look at the way I have written this formula. Okay, so a plus b whole square is equal to a square plus 2ab plus b square. All right, a square plus 2ab plus b square, that is a plus b whole square. Okay, now I can write this in a different form if I leave behind a square plus b square on one side, okay, and take the remaining 2ab on the other side. So a square plus b square will be equal to a plus b whole square minus 2ab. All right, a plus b whole square minus 2ab. Just give me 1 second, friends. I believe there is some problem with the streaming, so give me a few seconds for that. All right. So if I'll continue with this, we have seen a plus b whole square. Okay. So a plus b whole square is a square plus 2ab plus b square. So I have not written b square first. I have written a square plus 2ab plus b square. All right. So a square plus b square, if I'll keep this on one side, so a square plus b square will be a plus b whole square minus 2ab. Okay, so this is not a different formula. This is just I have derived from the first one. Okay, now the next one is a minus b whole square. That is a square minus 2ab plus b square. Okay, so this is the formula for this. Hi Harshal, Monish, good evening to both of you. Okay, now if I'll compare these two formulas, a plus b whole square and a minus b whole square. Now, sometimes a lot of students will take it as a different formula. I'm talking about this formula and this formula. You will tell me, yes, sir, these two formulas are totally different. But if you know this formula, a plus b whole square, okay, then you can easily write this formula by yourself. It will not only help you in this case, it will help you at a lot of places. All right, so let's see where it can help at a lot of places in the further formulas. So first of all, if you know this formula, then you can write this formula directly by, so it is a minus b whole square. Okay, so just replace b by minus b. Okay, in the original formula, just replace b with minus b. So a square will remain as it is. If I'll put minus b here, it will become minus 2ab. All right, and b square will remain as it is. So plus b square. All right, so a minus b whole square can be written as a square minus 2ab plus b square. The same thing can be applied whenever you have a plus b whole cube, a minus b whole cube. So we learn different formulas for a plus b whole cube and a minus b whole cube. There is no need to do that. You can reduce the burden from your mind and you can make your life a little easier. Okay, so don't remember the different formulas for a minus b and a plus b. Just remember one formula for a plus b whole square, a plus b whole cube, and so on, and just replace b by minus b. All right, so a minus b whole square can be written as a square minus 2ab plus b square. Okay, now if I'll keep a square plus b square on one side, then a square plus b square will be equal to a minus b whole square plus 2ab. All right, so no need to remember it separately, just keep it in mind at some place. Okay, and these formulas will be helpful. All right, now increasing a level little higher. Okay, talking about a plus b whole cube. So a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. All right, now just look at this formula and I'll also give you another way of making this formula simple for you. Okay, so remembering this formula is a little difficult. When it comes to a plus b whole raised to the power 4, it is further difficult. Okay, so I'll give you a general way of remembering the formula for a plus b whole raised to the power n. All right, but first of all, look at this formula because this formula can be used or will be used directly at a lot of places. All right. Siddharth, Raj, good evening. How are you people? Okay. Now, one way I can write a plus b whole cube as a cube plus 3a square b plus 3ab square plus b cube. All right. Now, if I take something common from this portion, I take 3ab common, okay, and will keep the remaining part as it is. Okay, so a plus b whole cube can further be written as a cube plus 3ab. Okay, so I'm taking 3ab common. So a cube plus 3ab bracket, it will be a plus b left over and b cube as it is. All right, fine. This is the second step. Further, what I can do is I can keep a cube plus b cube on one side. Okay, a cube plus b cube on one side and take the remaining part on the other side. All right, so it will become a cube plus b cube equals a plus b whole cube minus this portion, that is minus 3ab bracket a plus b. All right, now I'm taking this particular thing towards the factorization, towards the factorized form of a cube plus b cube. All right, in the next part, take a plus b common. Okay, so if I take a plus b common, then I'll be left with a plus b whole square minus 3ab. All right, now you may expand a plus b whole square and the final factorized form for a cube plus b cube will become a plus b multiplied by a square minus ab plus b square. All right. Now, each of these forms is very, very, very important. All right. Now, each of these forms, the four statements I have given, now all of them have originated from a single statement, from a single formula. All right. So, the next three statements that I have written, they have originated from a single formula, but each of these four statements, each of these four formulas can be used at different places and will help you at a lot of places. All right. Okay. Now let's move ahead and look at the next thing. Okay. So this was the formula of a plus b whole cube. Now, if I want to look at the formula of a minus b whole cube, remember the same thing that I have told you on the previous page. If you want to find out the formula of a minus b, okay, a minus b whole cube, just replace b by minus b in this entire expression. All right. So a cube as it is, instead of b, if I'll replace it by minus b, it will become negative of 3a square b. Then in the third term, b square, I have b square, so minus b whole square will remain positive, so third term will remain as it is, that is plus 3a square, sorry, plus 3ab square, and the last term b cube, so minus b whole cube will become minus b cube. All right, so basically what is happening here is I'm getting alternate plus and minus signs. All right, fine. Now the same three steps will be applied with this formula as well to obtain the factorized form of a cube minus b cube. Okay, so let's move ahead. Good evening, Purnima. So a cube minus b cube, if I'll go towards that, so first of all, a minus b whole cube, I'm taking something common again like I have done earlier. So minus 3ab can be taken common, and in the brackets I'll be left with a minus b. All right. Okay. Now moving on to the next step, I'll keep a cube minus b cube on one side and take the remaining part on the other side. So a cube minus b cube will become a minus b whole cube plus, so this will go on the other side and will become plus, will become positive. So plus 3ab into a minus b. All right. And the final step, from here I'll take a minus b common, okay, as done in the previous case. So I'll take a minus b common and I'll be left with a minus b whole square plus 3ab. Now you can expand a minus b whole square, and the final factorized form for a cube minus b cube will be a minus b multiplied by a square plus ab plus b square. Okay, fine. So this is about the cube formulas. Okay, the cubic formulas. Now here I'll give you the generalized form of this one. Okay, generalized form of these. All right, as well as the generalized form of the last step. So these are the two most important things: a plus b whole cube and a cube plus b cube. Okay, so a plus b whole cube and a cube plus b cube, these two things are used more frequently. Okay, so I'll tell you, in case instead of cubic power you have fourth power or you have fifth power, then how can you write this formula directly? So I'll give it this to you in the later stages today only. Okay, so let's continue. So these formulas are absolutely fine. Let's move ahead. And first of all, the general form of a plus b whole raised to the power n. So instead of n, if you have like 2, 3, 4, 5 or maybe any other higher power, so how to write the generalized formula for this? Now this particular expansion, if you have heard of the name, is called binomial expansion. Okay, so I'll use binomial expansion. So a plus b whole raised to the power n can be written as first term nc0. Now c is for combination. Okay, so permutation combination, if you remember that topic. So c is from combination. Okay, so nc0 into a raised to the power n. I'll definitely take an example. Okay, but I'm first of all giving you a generalized formula. Okay, so nc0 into a raised to the power n will be the first term plus nc1 a raised to the power n minus 1 multiplied by b Then NC2 will come. Okay, NC2 and a raised to the power n minus 2 b square. NC3 a raised to the power n minus 3 b cube, and so on. And finally, you will get the last term as NCN b raised to the power n. Now let's study this formula quickly. Okay. Now first of all, the coefficients, the constant terms, they are NC0, NC1, NC2, NC3, and so on up till NCN. Okay, so there is nothing difficult about this. Okay, so NC0, NC1, NC2, NC3, and so on. Hi Shivam, how are you? Samarth? Okay, I'll do that. Yes. Okay, so NC0, NC1, NC2, NC3, and so on up till NCN. Okay, this will be the constants, the coefficients. All right. Now look at the variable part. Look at the powers of A and B. So first of all, I started with highest power of A. So power of A is n, the number which was here in the power. So power of A is n, and with every term, the power of A is reducing. So A raised to the power n, then A raised to the power n minus 1, then A raised to the power n minus 2, n minus 3, and so on. And in the final term, the power of A is 0. So I can write A raised to the power 0. All right, fine. Okay. Now if you look at the powers of B, in the first term, the power of B was 0. Then power of B is 1, 2, 3, 4, and it increased to power n. All right. Okay. So basically, this expansion has three parts: the constant, the powers of A, and powers of B. The constants are NC0, NC1, NC2, NC3 up till NCN. Power of A, I started with highest power, kept reducing the powers of A. Power of B, I started with 0 power and kept increasing the powers of B. All right. So let's take it in an example. So how to write A plus B whole raised to the power 4? So if I write the constants, 4C0, the value of n will be 4. Okay, 4C0, 4C1, 4C2, 4C3, and 4C4. So these are constants. Then I'll start with highest power of A. All right. So A raised to the power 4 multiplied by B raised to the power 0. All right. Then power of A will kept reducing and power of B will increase. So next term will be A cube B raised to the power 1. All right. Then 4C2 multiplied by A square B square. Then further power of A will reduce, A raised to the power 1 B cube, and finally the power of A will become 0 and the power of B will become highest, that is B raised to the power 4. Okay, so this is how you can directly write the formula for A plus B whole raised to the power 4. All right. Okay. Now next, A plus B whole raised to the power 5 can be done in the similar way. So 5C0, A raised to the power 5, B raised to the power 0 plus 5C1, A raised to the power 4, B raised to the power 1. Again, I'm reducing the powers of A and increasing the powers of B. 5C2, A raised to the power 3, B square. 5C3, A raised to the power 2, B raised to the power 3. 5C4, A raised to the power 1, B raised to the power 4. And finally 5C5, A raised to the power 0 and B raised to the power 5. Okay. Now using this binomial expansion, you may expand any power of A plus B. All right. Now in CAT and in some other entrance examinations, you will see questions which are directly related to the binomial expansion. All right. So that will give you a push towards solving those type of questions. Okay. Now let's move further and look at a few questions on whatever we have covered till now. Okay. So very basic question I have given you. The question is A plus B a factor of A raised to the power 6 minus B raised to the power 6? Okay. So in the chat, in the comment section, quickly write yes or no. Okay. I'll wait for 10 seconds. Is A plus B the factor of A raised to the power 6 minus B raised to the power 6? Those who are attending this lecture, just write yes or no. All right. Is a plus b the factor of a raised to the power 6 minus b raised to the power 6? I'm waiting. Come on. All right, Siddharth says yes. Good, Siddharth. All right, so let's see. So first of all, to understand or to find out whether a plus b is a factor of a raised to the power 6 minus b raised to the power 6, I'll do the factorization of a raised to the power 6 minus b raised to the power 6. Okay. Now the previous formulas, the square formulas or the cube formulas, I'll be using to factorize this. Okay. So a raised to the power 6 minus b raised to the power 6, I have written it as a square whole cube minus b square whole cube. Okay. So a raised to the power 6 has been written as a raised to the power 2 whole cube. All right. Similarly, b raised to the power 6. Okay. Now I can see that this is nothing but x cube minus y cube. Okay. X cube minus y cube. I'll apply the formula. So x cube minus y cube का formula क्या होता है? Okay, I'll write it. So x cube minus y cube, you all may remember it. Okay, so it is x minus y and x square plus xy plus y square. Okay, in a few minutes from now, you will also easily recall these formulas. Okay, there is no need to cram these formulas. I'll give you a way of learning them. Okay, so I've written a square minus b square multiplied by a raised to the power 4 plus a square b square plus b raised to the power 4. Alright. Now further, this a square minus b square can be written as a plus b into a minus b. Okay. So further, a minus b into a plus b and multiplied by a raised to the power 4 a square b square plus b raised to the power 4. Now I can see that among the factors of this, I have a plus b present. So yes, I can say that a plus b is the factor of the given a raised to the power 6 minus b raised to the power 6. Now let's take one more question like this. So those who are there, again a question for all of you. Is a square plus b square the factor of a raised to the power 6 minus b raised to the power 6? I'll give you 10 seconds. Please write your answer in the chat box. Quickly, come on. So quickly write yes or no. Come on, Siddharth, Raj, Moniash, you have responded to the previous one. Shivam, Samarth, Purnima, come on, go ahead and give me an answer. Come on. Okay. So let's look at this. I'll do the factorization in a different way now. Okay. So I have shown you one way of factorizing. Okay. That way can also be used for a raised to the power 6 minus b raised to the power 6. But just to show you one more way of factorizing, let's talk about this. So earlier what I did was I have written earlier a raised to the power 6 as a square whole cube. Now in this case, I have written this as a cube whole square. All right, a cube whole square. So now this is the formula of x square minus y square. All right, x square minus y square, which can be written as x plus y into x minus y. I've used that earlier also. Okay, so let's write it. A cube minus b cube, a cube plus b cube. Okay, so a cube minus b cube and a cube plus b cube. Further, I'll write the factorized form of a cube minus b cube as well as a cube plus b cube. All right, so let's quickly do that. So a cube minus b cube can be written as a minus b multiplied by a square minus ab, sorry, a square plus ab plus b square. Okay, so it will have plus sign everywhere, and a cube plus b cube can be written as a plus b, a square minus ab plus b square. All right. Now, nowhere you can see a square plus b square among the factors of a raised to the power 6 minus b raised to the power 6. Okay, we cannot see that. All right. So, what I can say is, no, this is not a factor of a raised to the power 6 minus b raised to the power 6. All right. So, basically, the formulas that we have learned till now, they will be used to basically factorize any of the given polynomial. We have seen this particular thing yesterday. This is a different set of questions. All right. Okay. Now let's move one step ahead, one step higher. Okay. I have given you the general formula, general expansion of a plus b whole raised to the power n. right? I have given you this thing. Now let's talk about the general expansion or the formula for a raised to the power n plus b raised to the power n, and it will be used directly in a lot of questions. All right. Okay. So right now we know for a cube minus b cube or a cube plus b cube. Let's say if you have a raised to the power 5 plus b raised to the power 5. In CAT or ZAT, we have seen questions which will give you something like a raised to the power 95 plus b raised to the power 95. They will use as much high powers as possible. Okay, so let's see how to make things easy for us. Okay, so another general form. So first of all, a raised to the power n plus b raised to the power n. Okay, I'll explain this, don't worry. So a raised to the power n plus b raised to the power n. First of all, there is a small condition. It can be factorized like this only when the value of n is odd. So make a point, make a note, make a star, whatever you want. Okay, so a raised to the power n plus b raised to the power n. I have a plus sign here. So a raised to the power n plus b raised to the power n can be factorized when n is odd. So a cube plus b cube, a raised to the power 5 plus b raised to the power 5, and so on. Okay, so the factorized form is in the brackets, first of all, a plus b, simple. Okay, now in the next bracket, this is important. So don't look at the plus minus sign right now, just look at the terms. So I'll start with, so here the power of a is n. So I'll start with one lower power of a. Okay, I'll keep writing the example simultaneously, a raised to the power 5 plus b raised to the power 5. Okay, it will help you. All right. So I'll first of all write a plus b in the first bracket, and in the second bracket, I'll start with a raised to the power 4. Okay. Now it's simple. The power of a will be reduced and the power of b will increase. Okay, so keep decreasing the powers of a and keep increasing the powers of b. So next term will be a cube b. Next term will be a square b square. Next term will be a raised to the power 1 b cube. And finally, a raised to the power 0 b raised to the power 4. All right. So all of you already understand this thing because we have seen the binomial expansion earlier. Okay. But this is a different type of formula now. All right. So a raised to the power 5 plus b raised to the power 5. I have written as a plus b. And the next is in the brackets. Now talking about the signs, here we'll have alternate positive and negative signs. So already a raised to the power 4 has positive, then negative, then positive, then negative, and then positive. All right. So be careful with these signs. All right. So they will be alternate positive and negative signs. Am I clear to all of you? Yes or no? Come on. Okay. So this is how you can write the factorized form of a raised to the power n plus b raised to the power n when n is odd. This is very important. N should be an odd number. Okay. You cannot do it when n is an even number. Okay. Now let's go ahead and look at the next thing. A raised to the power n minus b raised to the power n. Okay. So what will be the factorized form of this? So again, I'll take an example and this will be applicable in both the cases for any value of n. When n is even, when n is odd, it will be applicable every time. All right. So let me take an example again for a raised to the power 5. Wait, I'll write it on the left hand side a little bit. So a raised to the power 5 minus b raised to the power 5. Okay. So the first bracket is a minus b. The terms in the second bracket will be written in the similar, exactly similar way you have done previously. Okay. So it will be a raised to the power 4. So I had originally a raised to the power 5 on the left hand side. So in this second bracket, I'll start with one less power. Okay. So a raised to the power 4 will start from here. I'll keep writing the terms in the similar way. A cube b, a square b square, a b cube, and finally b raised to the power 4. In this case, like earlier we had alternate positive and negative signs. In this case, all the signs will be positive. All right. So just apply all positive signs. That's it. This is over. So now by yourself, you can write the formula for a raised to the power 6 minus b raised to the power 6, a raised to the power 7 minus b raised to the power 7. Anything you can do now. Okay. Now this is one of the most difficult things that we have in CAT, and generally I've seen a lot of students leaving all these things. They just ignore all these things. Okay, but these things will help you at a lot of places. All right, like I said, making a difference. So from 95 percentile to 99 percentile, just a matter of 1 or 2 questions, you can increase your percentile by 2 or 3 percentages. Okay, so let's look at one of the questions that has appeared in previous years. Okay, and majority of the students have left this question. अब ये क्वेश्चन देखने में तो बहुत डिफिकल्ट लगता है. ओके, विच ऑफ द फॉलोइंग रेंज बेस्ट डिस्क्राइब्स द वैल्यू ऑफ m? माय गॉड. Okay, now the different options are given to you. M is less than equal to half, it is between 1 by 5 and 1 by 2, it is between 1 by 2 and 1, it is greater than 1. Okay, now the question is 99 raised to the power 99 minus 98 raised to the power 99. Okay, it is the numerator, and in the denominator I have 99 power 98 plus 98 power 98. Okay, now how to basically solve this question? In the numerator I have negative sign, in the denominator I have positive sign, so there is nothing which will make the value of m clear, that will it be less than 1, will it be greater than 1? If it is less than 1, then in which of these ranges, option 1, option 2, option 3, in which of these ranges will it lie? Okay, so Raj says I think B is the answer. Okay, so option 2, Raj, you are saying? Okay, fine. So let's have a look at it, Raj. So Purnima also confirms that answer may be option 2. Chalo, check karte hain if we are correct or not. So let's have a look at a way of doing this question. Okay, now I'll first of all consider the numerator only. 99 raised to the power 99 minus 98 raised to the power 99. Okay, and I'm going back to the previous page. I'll be using this expansion. Okay, a raised to the power n minus b raised to the power n. All right, so it will be a minus b, 99 minus 98. Okay, in the second bracket, it will be, let's write it properly. So 99 raised to the power 98, all the signs will be positive here, plus 99 raised to the power 97 multiplied by 98 raised to the power 1, plus 99 raised to the power 96 multiplied by 98 raised to the power 2, and so on. I'll keep on writing, and I'll just write the last step, which will be 98 raised to the power 98. All right, am I clear to each and every one of you? Yes or no? I hope. I've just copied that formula. Okay, I've done nothing else. Now in the first bracket, 99 minus 98 is 1. Okay, so this value is 1, so I'll completely ignore it. Okay, and we'll write the second bracket and rearrange some of these terms. Okay, so let me change the color. So I'll write this and this term separately because they are in the denominator. So 99 raised to the power 98 plus 98 raised to the power 98. Okay, first and last term I have written together, plus a lot of terms will come. All right, okay, and I'll close the bracket. Right? Are we on the same page till now? Are we together? Are we able to understand? Okay. All right. Now let me divide this. So let me introduce the denominator. So numerator was 99 raised to the power 99 minus 98 raised to the power 99 divided by 99 raised to the power 98 plus 98 raised to the power 98. On the right hand side, I have 99 raised to the power 98 plus 98 raised to the power 98 plus something. I call it k. Okay, so let me write k instead of the remaining terms. Okay, so plus k divided by 99 raised to the power 98 plus 98 raised to the power 98. All right. Now I hope all of you might be clear. Now in this expression that I have written on the right hand side, can I say that numerator is certainly greater than denominator? I repeat, can I say in this expression which I have written on the right hand side that numerator is certainly greater than denominator? Okay, so if numerator is greater than denominator, then what will be this value? Will this value be greater than 1 or less than 1? Come on. If numerator is greater than denominator, this value will be greater or less than 1. Come on, give me an answer in the chat. All of you, those who are attending this lecture, all of you must write their answer. All right, come on. Okay, there is a little lag, so I'll continue. So this will be greater than 1 because numerator is more than denominator. All right, so yes, Moniash has given the answer greater than 1. Good, Moniash. So this will be greater than 1. And what will be the answer in this case? Answer will be option number 4. All right, so uh, a difficult looking question. Okay, so this question was looking like a ghost. Okay, so a difficult looking question can be made easy in just 2 steps. So I have solved this question in 2 steps only. I have not done anything else. So 2 steps were required and the question is over. All right, okay, now let's move on to the next thing. Right, so the divisibility rules, some of them for a raised to the power n plus b raised to the power n and a raised to the power n minus b raised to the power n. So let's have a look at them one by one. Okay, and again, I'll ensure you that you are going to see some questions on this logic. All right, okay. So a raised to the power n plus b raised to the power n. Let's start from here. Okay, now it depends on the value of n. So if the value of n is odd, if the value of n is odd, as in we have a cube plus b cube, we have a raised to the power 5 plus b raised to the power 5, something like this. Okay, so if the value of n is odd, then a raised to the power n plus b raised to the power n will be divisible by a plus b. All right, it will be divisible by a plus b. When n is even, it will not be divisible by a plus b or a minus b. So it will not be divisible by any of these two. All right. So if n is odd, it will be divisible by a plus b. Yes, it will not be divisible by a minus b. Okay, it will not be divisible by a minus b, but it will be divisible by a plus b. When n is even, it will not be divisible by a plus b or a minus b. Right? Let's move further. For the next part, a raised to the power n minus b raised to the power n. So if n is odd, it will be divisible by a minus b and it will not be divisible by a plus b. Okay, but if n is even, then it will be divisible by both a plus b and a minus b. All right, so please make a note of it very quickly in your mind. All right, and let's see one very basic example on this. Okay, I'll not call this example basic because this has appeared in previous year examination. Okay, so yes friends, I am picking questions from previous year papers. So question is, what is the remainder when the given expression is divided by 70? Okay, now I'll break this question in 2 parts. I'll write 70 as 35 into 2. Okay, now consider this expression. I'll combine 16 cube and 19 cube together. Okay, and I'll write 17 cube and 18 cube separately. Okay, now this is a cube plus b cube. Okay, a cube plus b cube, or this is a raised to the power n plus b raised to the power n. Now when n is odd, a raised to the power n plus b raised to the power n is divisible by a plus b. So this value will be divisible by 16 plus 19. That means 35. Okay. So first part will be divisible by 35. Using the similar approach, 17 plus 13. So this term will also be divisible by 35. Okay. So if both these terms separately, both these parts are separately divisible by 35, so I can say that the entire expression will be divisible by 35. Okay. So this entire expression now is completely divisible by 35, right? Okay. Now out of 70, which I have written as 35 into 2, this expression is already divisible by 35. Now, if this expression is also divisible by 2, then I can say that the entire expression will be completely divisible by 70 and hence the remainder will be 0. Okay. Now let's check 16 cube plus 17 cube plus 18 cube plus 19 cube. Okay, now let's look at the nature of this expression. Will this expression be odd or this expression will be even? Okay, so can you all quickly write about the nature of this expression, even or odd? Come on. So I'm waiting. Okay. Meanwhile, I'll start solving. So 16 cube is even, 17 cube will be odd, 18 cube will be even, and 19 cube will be odd. Alright. Now I'll keep these two even numbers separately. So even plus even is even. Also odd plus odd is also even. Alright. And finally even plus even is even. Okay. So I can say that no Raj, this expression will definitely be even. Okay. So this entire expression will be even and hence it will also be completely divisible by 2. Every even number is divisible by 2. So this entire expression is divisible by 35 as well as 2. Hence this entire expression will be completely divisible by 70 and hence the remainder will be 0. Alright, that's it. So very simple application, a very basic application of whatever we have learned on the last screen. Okay. Let's move ahead and look at the last set of formula. Okay. So a plus b plus c whole square. You can expand this, you can make the formula by yourself, but it's better to learn this formula. So a square plus b square plus c square plus 2ab, 2bc and 2ac. Okay. So this is the formula for a plus b plus c whole square. Now if you want to write the formula for a minus b plus c whole square. So again, I have told you what you have to do. Instead of b in the entire expression, replace it by minus b. Okay, so it will be a square plus b square because minus b square will be b square only plus c square. Now instead of b, negative b will come here. So minus 2ab. Again minus b will come here. Minus 2bc. And this expression, sorry, this term will remain as it is, 2ca. Okay. So this is the formula for a plus b plus c whole square, or if you have any change in sign, you can adjust it accordingly. All right. Okay. Now next is again the last important formula, a cube plus b cube plus c cube minus 3abc. This in factorized form can be written as a plus b plus c multiplied by a square plus b square plus c square minus ab minus ac minus bc. A very lengthy formula, I can understand. Okay. But this form or this way this formula is not used. So this form of this formula is not used frequently. Okay. Now forget about this thing right now. In the above formula, if this part will become 0, which is written down there, okay, if a plus b plus c becomes 0 in this formula, then can we say that the entire right hand side will become 0? Definitely. Okay, so I can say that a cube plus b cube plus c cube minus 3abc will become 0. Okay, so if a plus b plus c is equal to 0, then a cube plus b cube plus c cube minus 3abc will become 0. Okay, you can take 3abc on the right hand side and can say that a cube plus b cube plus c cube will be equal to 3 times abc if a plus b plus c equals 0. So this part of the formula you can keep it with you. Okay, and this part of the formula is a lot of times used in our examinations. All right, am I clear? Chalo. Now to end with, let's end this session with one last question. All right. So if A, B, and C are such that the relation between A, B, C and is given here. Okay. So A plus B upon C is equal to -1. Also, the product of A, B, and C is given to us. Then we have to find the value of A cube plus B cube plus C cube. Now, will I be able to apply the last result that we have seen on the previous slide? I'm talking about this result. Now, this result can only be applied if A plus B plus C is equal to 0. Okay, so let's look at this part. A plus B upon C is equal to -1. I'll do the cross multiplication. So A plus B will be equal to minus C. Meanwhile, those who can write the answer, they may write the answer in the chat box. A plus B plus C, taking minus C on the left hand side, will become 0. So now, yes, we have A plus B plus C equal to 0. So I can apply the formula that A cube plus B cube plus C cube will be equal to 3ABC. All right. Now this value we have to find out. I can write it as 3ABC. Okay. Now the value of ABC is also given in the question. So 3 times 1 upon 12, and the final answer will be equal to 1 upon 4. Let's see how many of you have written the answer. Again, Monish has written the answer. Wonderful, Monish. You are always on your toes. Raj, it will not be 0. It will be equal to 1 upon 4. Okay. Obviously, you must have seen the solution. Okay. So final answer will be equal to 1 upon 4. Fine. So friends, that's it from my side for the day. So this was algebraic expressions. Please stay tuned for the further sessions on algebra. Okay. Fine. So that's all from my side. And immediately right now, if you have liked this session, please do press the like button. All of you, all the students who are right now in the lecture, please do press the like button and do post something in the comments. So this was the chat box where you were posting. Please post something in the comments about this session. If you have any question, you may post that. Okay. And please subscribe this channel for regular updates. This is the entire schedule for the week that we run at BYJU'S Exam Prep, basically YouTube channel. So this is the entire schedule for the week. You may take a picture and you'll not miss any session. You can have all free lectures at one place. Look at a link in the description where you'll find the links for all CAT, MHCT and other MBA examination lectures free of cost at one place. Now friends, tomorrow MHCT examination is going to happen. So it is happening in the next 3 days, 16, 17, 18. So if any one of you is taking this examination, you can join us for live analysis on YouTube. Okay, so we'll be discussing some key features of the slots for which exam has already happened. All right, and it will be live on all the 3 days, 16th, 17th and 18th at 12 noon and 5 p.m. All right, so you may join us for the live analysis of MHCT 2021. Okay, now this is the information about the different CAT courses and the other MBA examination courses that we run here at BYJU'S Exam Prep. Now one of the batches that we run, especially for the aspirants who are looking for SNAP, NMAT, CMAT and TISNET preparation. So these are the details for that batch. This is the list of experts that we have on our panel. Now other online classroom programs for CAT 21, a percentile booster course and a complete course for CAT 2022. These two are given on your screen with the complete details. All right. So friends, that's all from my side. Thank you very much. You can follow us on Instagram, Facebook, join us on Telegram and subscribe this channel. All right. So thank you very much. Thank you for attending this session. I'll keep coming back to you again and again with these simple sessions so that you can increase your percentile in the examinations. That's all from my side, friends. Thank you very much.